We'll be looking at solving absolute value equations and inequalities. So there's a little bit of difference on getting started within those, but a lot of the concepts work just like solving equations. So most people are not going to find this one too terribly difficult. Now, an absolute value is a distance from zero. That's the definition of absolute value. So anytime that you're dealing with a distance is measured in a positive number, but the actual value may have been to the left of zero in the negatives or to the right. When we say the absolute value of a number is a, then that's like saying x is either the a value to the right of zero or x is the a value to the left of zero. So it could be positive or negative. When we only have an x, we only have one particular value. This is pretty easy. If the absolute value of x is 3, then either x was 3 or x is negative 3. Expressions, though, inside of the absolute value area can get a little bit more complex. So what you have to do is remember to set them up exactly in the same way, even if you don't see it kind of ahead of time. So you're going to start out by saying that it's exactly the same as written. So this 3 was the same as written. And then the other possibility is that it's the opposite. So if you have several things in there, we will just deal with it's either the same or it's the opposite. So when we have this, we start off then with two separate equations, and they are an or. We've got either 3x plus 2 is equal to 1, or 3x plus 2 is equal to negative 1. After you set it up like that, we are solving it just like we've solved everything else. So subtracting 2, 3x is negative 1, x is equal to negative 1/3, or 3x is equal to negative 3, and x is equal to negative 1. Now these are a great idea to check, but I'm not going to check them all on the calculator, because this time when you're checking, you are sincerely looking for your own errors to make sure you didn't make a mistake, not that concept that it's not going to check. We do have a couple of exceptions to that, but I'll show those as we go. So here we have two answers, and I believe in the homework they ask you to put them in set notation and just list them like this. So again, you're going to start off by saying, okay, it's either exactly like it's written when I drop those absolute values, or it's the opposite. So you keep that first one, 1/2 x minus 5, and say, or it equals the opposite of what it said. Then we solve. I add 5, 17 plus 5 is 22. Multiply by 2 to get rid of the 1/2. You could divide by 1/2, but it ends up being the same thing. If you add 5 to negative 17, though, you get negative 12. And then x is equal to negative 24. I have had students that want to just work out the problem and then say it's either that or the opposite, but you can see that that is not the case. You have to do the opposite on that very first step. It's either like it's written or it's the opposite. And then you'll get your two different answers. Now, I've also had students say, well, I didn't think absolute value could be negative. Well, we didn't say the absolute value was negative, but you can take a negative number and plug it in for x. So like if you took half of negative 24, you would get negative 12. Negative 12 minus 5 is negative 17, but then the absolute value of that is 17. So you can use a negative inside absolute value, just the result of it is not going to be negative. If they don't have the absolute value all by itself, you do need to isolate it first. So in this case, the first thing you want to do is subtract 2. So we have the absolute value of 5x plus 4 is equal to 3. After that, though, it works the same way. It's either exactly as written, or the expression is equal to the opposite of what it said. Work them both out. So my two answers. Now, I am not certain right here, but I do know sometimes on the homework they ask you to list your answers from least to greatest. So make sure you read those instructions carefully. I did that here, but I did not do that on the other one. But if they want you to list the answers from least to greatest, make sure you pay attention to that. Here, if I subtract 9 from both sides, then divide both sides by -1 to get rid of that negative that's in front of my absolute value. Now I'm ready to do the same thing we were doing. It's either as written or the expression is equal to the opposite of what it said. When we have greater thans and less thans, it does get a little bit more going on, because if it is a less than, they have to be between two things. Like if your distance from 0 is less than 3, then that means the number you're picking is between -3 and 3. So whenever you have a less than, an absolute value is less than, you should expect things to be between. However, if your absolute value is greater than, it means you're moving further away, and you can move further away to the right or to the left, but you can't do it at the same time. So whenever you're dealing with those, you end up with two separate things. And you will have to graph these solutions on a number line. And so do remember that when you're doing that, and I'll give some examples coming up, but strict inequalities will be open intervals or parentheses. And then the ones that say or equal to can use the brackets. So let's do some inequalities with absolute value. First of all, this one is a less than, so I can write it between. I can say my expression is between . Now you do want those arrows to always be pointing the same direction. That makes a difference between the -13 or the 13. Now I'm going to back up for just a minute so you can now see how I've written that compared to what was there. If we have an A here, but you've got a less than, you start with the opposite of A, less than your expression, less than A. So this right-hand side ended up being just like it was written. And then over here on this left-hand side, I ended up putting that opposite number. So now taking this to this next one, this right-hand side, 3x plus 4 is less than 13, is exactly like it's written. And then in front of it, I put the opposite. When we solve something like this compound inequality, we can work on all three sections at once. So I can subtract 4 from all three sections, the left, the center, and the right. So -13 minus 4, -17. Here, I just get 3x. And then over here, 13 minus 4 is 9. Generally, you want to divide all three sections because I'm dividing it by 3. I'm trying to get x by itself. So now I have -17 over 3 is less than x, which is less than 9 divided by 3 is 3. Interval notation. This is strict inequalities, so it uses parentheses. It goes from -17 over 3 up to 3. So that is my solution set written in interval notation. Now, if I were going to graph it, what we know is that there's a number line. I'm not worried too much right now about putting all my little tick marks on there. We know that somewhere there's a -17 over 3 and somewhere there's a 3 to the right of that, so it doesn't matter which one is to the right. But when you have to graph these online, what's really going to happen then is you're going to put parentheses on your number line at your endpoints, and then you'll put that little thing on there. So it'll look like that when you're doing it online. Let's look at another one then. This one is a greater than. It does say or equal to, but I'm just going to be copying that over. So let's just go back and remind you of how to set that up. If it's a greater than, you have to set it up with two separate statements and use an or in between them. The right one of these statements is exactly like it was written. See, this says X is greater than A, and one of our statements over here was X is greater than A. But when we use the opposite, when you put that negative in front, you also have to flip that inequality. So you want to flip that over and do the opposite. One of them, the one that I'm going to put here on the right, will be exactly as written. 2x minus 1 over 3 is greater than or equal to 5, 6. But my other possibility is that 2x minus 1 over 3 was less than or equal to negative 5, 6. Because you flip the inequality and change the sign there. Now, once you've got that done, you're going to solve this just like you would any other inequality, which, keep in mind, only means that you flip an inequality symbol if you multiply or divide by negative, but otherwise we're just cranking things out. So first of all, since I'm trying to get x by itself, I'm going to multiply both sides by 3. When I multiply both sides by 3, those 3's are going to cancel, and I get 2x minus 1 is less than or equal to. Now 6 will reduce with the 3, and so I get negative 5 over 2. Now add 1 to both sides. 2x is less than or equal to, I'm going to change this to a decimal since it will be a nice decimal. That's negative 2.5 plus 1 is negative 1.5. It is negative 3 over 2. This was just an easier way for me to think about it. And then if I divide both sides by 2, x is less than or equal to negative 0.75 or negative 3/4. Either way you want to do that. You just can't round the decimals. As long as it's exact, you can use it. Working on this other one, doing the same sort of thing at the beginning. I've got to multiply both sides by 3. So I get 2x minus 1 is greater than or equal to, but now when I reduce it, this is a positive 5 over 2. So when I add 1 here, this is 3.5. And then if I divide up both of them by 2, I get x is greater than or equal to 1.75. So if you needed to graph this one or you've got to write it in interval notation, this is going to have to take 2 intervals. Ooh, such a bad line. Okay, but again, we know somewhere there's a negative 0.75, and somewhere to the right of that, there's a positive 1.75. So what is this going to look like on the number line when you graph it? This one, because it says or equal to, will be closed, which means you're going to use that bracket, and it's going to go to the left. Ooh, such a bad line. And then this one is going to be a bracket and head to the right. Let me just kind of clarify then. This is why I said before that if it was less than, it would be between, together and between. Let me just show you that again. See, I said less than will be between and together. We wrote it in between for the equation, and we ended up graphing it together. That's what this graph was. The other one said different and separate. We had to write 2 different inequalities to start, and they ended up going separate directions. Now, I'm also supposed to write this in interval notation, and I've certainly run myself out of room at the bottom. So I'm going to write that interval notation just kind of up here at the top. What would that interval notation be? Well, interval notation goes from the left to the right, so it's coming from negative infinity, always open at infinity. It goes all the way up to negative 0.75, and it is closed there. Then we union that with 1.75, closed at 1.75, to infinity. And that would be our answer solution set in interval notation. It is possible to have no solution or infinitely many solutions. What I hope you do is pay close attention at the very beginning when you get your absolute value isolated. As you know from past experience, the absolute value of whatever has to be greater than or equal to 0. This one says it's equal to a negative. -3 is not greater than or equal to 0, so this one is no solution. On the other hand, any absolute value is going to be greater than a negative number because any absolute value is greater than or equal to 0. So this one is all solutions. So if I needed to write these answers then, don't forget the no solution is an empty set, which generally we use the symbol, but that's the same thing. All x's is from -infinity to infinity. Now, if you don't notice that, and you end up working these out, you're going to get an answer. But when you try to graph it, it's not really going to work right. I mean, if you just, I hate to even, I hope none of you do that. I hope you're paying attention to it. But on this one with the -3, if you worked it out, you would say, well, x plus 7 is either equal to -3 or x plus 7 is equal to the opposite of -3. So here we get -10. And then you get -4. So it looks like we have two answers, but they don't check. -10 plus 7 is 3, but then the absolute value of that is not -3. So if you're not going to pay close attention at the beginning, you do need to check your results. Okay, it is okay to have a negative number for x, but when you plug it in, it's not okay for that absolute value to equal a negative. Now, on the other hand, even though I see a negative here, all absolute values are bigger than a negative. So these all work. If you did this one, what would happen is that, and I'm just going to shortcut over here, if you graphed this one, what ends up is if you have an arrow headed to the right and you have another arrow ended to the left, but since it's an or, that ends up being the entire thing. If you have an or and they overlap, it ends up giving you the entire response. So you could have no solution or infinitely many solutions there. Now, at this point in time, on your homework, they're going to ask you some review questions. So we're just going to very quickly write some of these concepts down. I'm not working a lot of examples, and it's for this one and the next slide. We've already finished the new material. If you don't need to review, you've reached the end of that new material, but you're going to have a test coming up. So just to kind of get a few things out. The distance formula finds the distance between 2 points. The distance is equal to the square root of. Subtract the x's and square it, and then subtract the y's and square it. And then when you take that square root, that's your distance. The midpoint formula. The midpoint formula is a point, and you get it by averaging the x values. So you add them and divide by 2, and then average the y values. A function. There's several things we've learned about a function. A function passes the vertical line test, and every x, or every element of the domain, goes to exactly one element of the range, which is a y value. A relation can be any XY mapping. It can be written in. They can be it doesn't have to pass a vertical line test. And it can also come as just a listing of ordered pairs, or it could be written like an equation. So any XY pairing will give you a relation. An x-intercept occurs whenever the y value is 0. A y-intercept occurs whenever the x value is 0. Perpendicular, you determine if lines are perpendicular if their slopes are negative reciprocals. Negative reciprocal slopes. Negative reciprocal was the math term, but that means that you are going to change the sign. That's going to make negative. And the reciprocal means you have to flip it over. So like if the slope of one line is 2/3, the slope of the perpendicular line would be negative 3/2. Parallel lines have the same slope. Horizontal lines have a slope of 0. And the equation of a horizontal line is y equals. Vertical lines have no slope, or the slope does not exist. Okay, it's undefined. And the equation of a vertical line is x equals your number. Things that are symmetric with respect to the x-axis, it's not a function. Also, if it is symmetric with respect to the x-axis, then what happens is that your x value will have two different y values. So y and negative y go with the same x. Symmetric with respect to the y-axis is a function. Furthermore, if you plug in a negative x, it will give you the same y value in x. And those functions are even. If it is symmetric with respect to the origin, if you plug in a negative x, then you end up getting the opposite y. These are odd functions. Don't forget, increasing, decreasing, and constant come from the left. They are open intervals, and they deal with x values. Even though you're thinking about going up and down, open, left, and x values. So those are all concepts that you'll need to review some as we're finishing up, because following this, take the test. This is the end of chapter 3 and the end of this video.